In 2017, a paper with 8 authors changed the world. Attention is all you need. Introduce the transformer architecture. It's behind GPT, BERT, Claude, Gemini, DALL-E, and virtually every state-of-the-art AI system today. Let's understand how it works. Welcome to episode 16, the most important episode in this series. The transformer is the architecture of modern AI. Understanding it is non-negotiable if you want to understand how AI works today. RNNs process tokens one at a time, sequentially. This makes them slow and forgetful over long sequences. Transformers process all tokens in parallel using a mechanism called attention. Each token can directly attend to every other token in the sequence. No sequential bottleneck. No vanishing gradients. Just pure parallel attention. Self-attention is the core innovation. For each token, we ask, which other token should I pay attention to? The word in the cat sat on the mat because it was tired. It needs to attend to cat. Attention computes this automatically using 3 vectors. Query, what am I looking for? Key, what do I contain? And value, what information do I carry? The attention formula is elegant. Take the query and key matrices, compute their dot product, scale by the square root of the dimension to prevent huge values. Apply softmax to get attention weights between 0 and 1, then multiply by the value matrix. The result, each token gets a weighted blend of information from all other tokens. Multi-head attention runs this multiple times in parallel with different learned projections. The full transformer has an encoder and decoder stack. The encoder processes the input through self-attention and feed-forward layers. The decoder generates the output token by token, using mass self-attention so it can't peek at future tokens, plus cross-attention to the encoder. Layer normalization and residual connections keep training stable at depth. Since transformers process all tokens in parallel, they have no inherent sense of order. Positional encoding solves this by adding position information to each token embedding. The original paper used sinusoidal functions at different frequencies. Modern models like GPT use learned position embeddings. This tells the model that the cat sat is different from sat the cat. The transformer family tree has 3 branches. Encoder-only models like BERT are great for understanding text, classification, named entity recognition. Decoder-only models like GPT are great for generating text. Encoder-decoder models like T5 are great for translation and summarization. Most modern LLMs use decoder-only architecture. The transformer is the most important architecture in AI today. Self-attention, parallel processing, and the ability to handle long contexts made it unstoppable. Next, large language models, how GPT and Claude actually work. This is going to be incredible. Subscribe.